This is section 5.2 for intermediate algebra. I'm Dr. Scott Franklin. In this section, we're going to follow up our discussion, our topic of polynomials. Having defined them and added and subtracted them in the last section, we're now going to discuss how we multiply polynomials. In section 5.2, we're going to first talk about how we just multiply monomials. Remember, monomials are those terms, or are those types of polynomials where there's only one term. Then we're going to multiply a single term times any polynomial, no matter how many terms it has. And then we're going to talk about how we multiply two polynomials together. And then there's the special case where if we have a binomial times a binomial, there's a little shortcut rule called FOIL to remember. It's actually the same rule that we use to multiply polynomials, but when there's only two parts, we give them special names, and we call it FOIL. Actually, there's another name for it that I will introduce to you that I was taught whenever I was in algebra way back in the 8th grade, 9th grade, something like that. And then last of all, we'll talk about squaring binomials. So here's what we remember whenever we are multiplying monomials. That is, we're going to multiply two monomials together, or to each other. We're going to multiply the coefficients and then use the power rule for exponents. That is, the rule that says when you have like bases, you add the exponents. Okay? So in this example, what we do is we put the like things together. So 6 times 3 is 18. Okay? All I did was 6 times 3 and I got 18. If I did x to the 4th times x to the 7th, right, that's going to be x to the 11th. And then y to the 2nd times y, 2 plus 1 is 3, so that's y cubed. All I do is multiply the coefficients together, and then when you're multiplying the variables, you combine like bases by adding their exponents, and that would be what we get when we multiply two monomials together. That's all there is to it. Now, when you multiply a monomial by a polynomial, we use the distribution law. We distribute the monomial. So, for example, when you see 6x cubed times the polynomial 3x to the 5th minus 5x squared plus 7, we're going to multiply this times each term. We've done this before, but now it's just in the context of talking about polynomials. 6x cubed times 3x to the 5th would be 6 times 3 is 18. X to the 3rd times x to the 5th is x to the 8th. 6 times a minus 5x squared is minus 30 x to the 5th, and 6 times 7 is plus 42 x cubed. Okay, and that's it. We can't combine like terms because there are no like terms. That's the final form of your answer. Okay, now for the big one. Whenever we're going to multiply any polynomial times any polynomial, this is the rule that you've got to remember. So when multiplying a polynomial, no matter how many terms there are, by another polynomial, we distribute, just like we did before, but here's what we do. We distribute every term in the first to every term in the second. Okay, so take, for example, if I had sorry, I didn't include this in your notes. We can write this down. Let's take a plus b times a squared minus ab plus b squared. Let's multiply these two polynomials together. What I mean to do is you take the first and distribute it to every term in the second. That's what you start with. Okay, and I'm always going to draw these arrows to indicate that. So a times a squared is a cubed, right? Because a to the 1st times a squared, 1 plus 2 is 3. A times minus ab, a times a is going to give me a squared, it's going to be minus, so a squared, and I've still got the b. And a times b squared is going to be a positive ab squared. Then we come back and we distribute the second term to every term in the second. So we take the second term in the first polynomial, distribute it to every term in the second polynomial. That's what you always do. So b times a squared, I'm going to write that as a squared b. B times minus ab, I've got a minus a and then the b's together would be b squared. And then b times b squared would be plus b cubed. Now let's not circle our answer yet. Let's first check and see if there are any like terms that we can combine. A cubed is the only a cubed. Minus a squared b and plus a squared b. Notice what happens to those. Minus a squared b plus a squared b minus 1 plus 1 gives me 0, so they completely cancel out. Ab squared and a minus ab squared also completely cancel out. So all I'm left with is a cubed plus b cubed is what we get when we multiply that out. But the main rule you're learning here is to distribute to the first term of the first polynomial to every term in the second term to every term in the second, and you just keep going. Always distribute all the terms in the first to every term in the second. As I mentioned earlier, there is a special rule for binomials times binomials. Now realize the rule I just mentioned, the rule that says you can distribute every term in the first to every term in the second, is valid for anyone. So it works for binomials times binomials. But like I said earlier in the introductory slide, we can give special names to that when you have a binomial times a binomial. Okay, when you have something like ax plus b times cx plus d, you got two terms in the first and two terms in the second. So what you do is you take the first one times the first one, which is where we get f for firsts, right? You take the first one times the last, the second one times the first one, and then the second one times the second one. You've got firsts together, the outsides, the insides, and the last, which is where we get FOIL, first, outside, inside, last. Now, just for kicks, let me show you what I was taught when I first learned this. If I had AX plus B times CX plus D, this was the problem that was given to me whenever I was first taught how to do this. Let me scoot this down a little bit. I was not taught FOIL. I never learned the term FOIL until I got to college and I was tutoring other students that were taking this class. And they said, oh, you mean just FOIL? I was like, no, it's not called FOIL. You take the firsts together, the outsides, the insides, and the lasts. That's clearly the monkey face rule. Right, you got the eyes here, here's the chin, you got eyebrows, you got the eyes right in the mouth. So it was the monkey face. So if I slip up at some point in this lecture series from this point on and say, all right, let's now monkey face it, you now understand that monkey face is in fact a verb. It just means to do the multiplication trick that I taught you. Okay, so monkey face, verb, means FOIL. FOIL means multiply out by distributing. Okay? All right, let's do an example. We have 4x plus 3 times 5x plus 1. So I start with the firsts. 4x times 5x is 20x squared. 4x times 1 is plus 4x. 3 times 5x is plus 15x. And 3 times 1 is plus 3. Combine like terms, I end up with 20x squared plus 19x plus 3. That's my final answer. Okay. Next one. X times 3x is 3x squared. X times 2y would be plus 2xy. Generally put the variables in alphabetical order, but there's no rule that says we have to do that. Negative 4y plus or times 3x is going to be negative 12xy. Negative 4y times 2y would be a negative 8y squared. Again, combining like terms, I end up with 3x squared minus 10xy minus 8y squared. Now in this one, we've got a problem that looks a little bit different. we have x minus 10 squared. And while it may be tempting to try squaring each one of those, we would actually be incorrect if we tried squaring the x and squaring the 10 and being done with it. Now what's wrong with that is the fact that you got to remember what squaring means, right? Squaring by definition is to multiply something times itself, right? So x minus 10 quantity squared means x minus 10 times x minus 10. Okay, so if you want to square that, that's what you got to do. Whenever you see a binomial squared, you have to multiply it times itself, and to do that, you have to FOIL. Okay, x times x gives me x squared. The outside gives me minus 10x. The inside gives me minus 10x, and the last gives me plus 100. So that's x squared minus 20x plus 100. If we had just squared the first and the last terms, we would have missed the middle term. Okay? So that's very important. When you see a binomial squared, always multiply it times itself. You got to use the distribution rule, or FOIL, or monkey face. Okay? All right, that's the end of section 5. That's not the end of section 5.2. We got one more problem. Sorry, I didn't see my notes. All right, one more. Oh, ho, 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 ho. Look at this problem. What do we got? We've got 3 polynomials multiplied together. Ooh, that's got to be super tricky, right? Wrong. It's actually fairly easy. If I were to say give you 3 numbers, 2 times 3 times 5, how do you multiply those together? Do you do it all at once? No, really what you do is you multiply 2 of them together, take the answer and multiply them times the next, right? I'd go say left to right. 2 times 3 gives me 6. 6 times 5 gives me 30, right? Or I very well could have done the second 2, right? I could have done 15 times 2 and get 30. It doesn't matter how I group them. I could even do 10, right, the outside, times the middle one, right? So the outside together is 2 times 5 is 10, times 3 is 30, right? You get the same answer no matter how I group them or order them. Same's true with binomials, or with polynomials. All I'm going to do is I'm going to group 2 of them together, multiply that, take the answer of that, multiply it times the other. So let's multiply the first 2 and let the last polynomial just hang out for a while. Okay, so first outside, inside, last. 2x times 2x is 4x squared. The outside, minus 5 times 2x is minus 10x. The inside is 5 times 2x, so plus 10x. And the last would be 5 times minus 5, or minus 25. That's what I get when I multiply the first 2 together. Okay, I haven't done anything with the last one, so I'm just going to leave it there attached to the end by multiplication. So it's just multiplied on. Let's simplify inside these parentheses before we multiply again, because I can combine those. In fact, they cancel out, minus 10x plus 10x. And I'm left with 4x squared minus 25 times 4x squared plus 25. Now we multiply again. So outside is 16x to the 4th. Inside, sorry, not outside. First is 4x squared times 4x squared, 16x to the 4th. 4 times 25 is 100, so 100 x squared. Minus 25 times 4 is minus 100 x squared. And then minus 25 times positive 25 is minus 625. Combining like terms, the middle terms again cancel, and I'm left with 16x to the 4th minus 625. There's my final answer. And that's the end, finally the end, sorry, of section 5.2. Got it right that time. Okay? So, next we're going to be talking about how to kind of divide what's called factoring polynomials.